Okay, so the first thing we're going to do today is just kind of review actual equalities, such as like 5x plus, say, 12 equals 13 or something like that, right? And I want to solve for x. So again, in order to do this, I need to bring this 12 to the other side. Right? And we can do this by adding and subtracting. And again, adding and subtracting moves things around. So if I subtract 12 on both sides, I would say we get 5x is still left, right? But positive 12 minus 12, they kind of just zero out, right? Because 12 minus 12 is 0. So then 5x plus 0 is just 5x. This equals this equals 1. And I guess if I just solve for x, I would divide by 5. Right? And this right here, this is just a fraction, and it's okay. If that's just a fraction, I'll keep it like that. X is just 1/5, right? So x equals 1/5. Now again, this is an equality. That means that 1/5 is the only number that goes inside this the 5x, or inside this x right here. 1/5 is the only solution for x that satisfies this entire equality right here. Okay, an inequality, there are going to be multiple values, and we'll kind of go over that right now. So let's go ahead and just set up an inequality. So just to review inequalities, so I guess not really a review because I haven't really looked at them yet. An inequality would be something like this. You know that, so let's say 5 is larger than 2, right? And obviously 5 is not equal to 2, so what kind of symbol would I put in here? Right? So the way that I was taught is that this right here is a symbol for greater than, because 5 is obviously greater than 2. And the way that you remember which way the sign goes, I was taught, is to make this Pac-Man, right? And Pac-Man obviously is hungry and he wants to eat the bigger number. So if I had something like this, let's say 12 and 100, well, which one would Pac-Man rather eat? Pac-Man wants to eat this one right here, right? And the way that we would read this, we would say that 12, and obviously, you just have to know which one's greater than. So 12 is obviously less than 100, right? So that's literally how you read this. 12 is less than 100. And again, inequalities, they behave just like regular equalities. So if I had something like 2x plus, let's say, 12, let's say this is greater than 24, right? And again, we want to solve for x again. So again, same thing. Subtract 12 on each side. This is 2x. This goes away. And I have 2x is greater than the number 12. We can divide by 2. And again, remember what I said before is that inequalities, they behave the same thing like equalities unless you multiply or divide by a negative number. If that ever happens, you just flip the sign over. And we'll do an example, and actually we'll see why that is. So the 2's cancel. You have x is greater than 6. Now, what does this mean? X is greater than 6. Well, think of a number that I could put in for x that would make this make sense, right? So I could do 8 is greater than 6, right? That makes sense. 8 is a bigger number than 6, and my Pac-Man would rather eat that the 8, right? And then say anything like 12 is greater than 6, so that makes sense. 2 is greater than 6. that doesn't make sense. So I can't just go ahead and put that 2 in there. That doesn't make any sense. So how do we represent this on a number line? Right, that's how you, well, a number line is actually used to represent the solution set for x is greater than 6. So what I do is usually I just kind of like make a small number line. It doesn't have to be that big. I usually like to put 0 in the middle, just for symmetry, and I'll put 6 here. And just for symmetry again, I'll put -6. You don't have to put really any other numbers. You know, you can if you wanted to. You could put like maybe 3 here, -3 here, 9, whatever. But this isn't really required. Really, the only thing that's really important is that you have 6 on here. And so what you do is you just put like and there's a bunch of ways to actually display this. Some people, they'll put a circle above it, right? Some people actually put a circle right on the number line. I like it that it's above this because I can actually see the line that I'm going to draw. So think, the numbers that we used 8 is greater than 6. We used 12 is greater than 6. Where are those numbers? Those numbers are in this direction, right? So really what this means, this line right here, is that, okay, so 6 I actually can't put in because 6 is not greater than 6. It's actually equal to, right? So 6 doesn't work, but like 6.1, you know, so like that's like right there, and 6.2 and 6.3 and 6.4. Here's 6.5, or actually that's, I don't know, that's actually 7 or 8 because that's going from 6 to 9, but you know what I mean. So it's like all these numbers work, all these numbers work, all of them, forever and ever and ever, and you know, all the way. So this arrow just means that it's all of these numbers, but I'm not going to be able to list them all because there's a lot of them. So it's just, you know, all these ones in that direction. All right. If we wanted to do, let's say, x is less than 2, right? So again, I just make a very simple graph. I put 0 here, 2 here, and -2. Really, that's my number line right there. That's all I need. You know, because here's 1, here's -1 or whatever. What I'm going to do is I'm going to put a circle above the 2. And I think, what numbers can I put in here that would make this make sense, right? I can't put 10 because 10, again, this is Pac-Man is trying to eat the 2 because the 2 is the bigger number. So this is x is less than 2, right? So these are numbers that are smaller than the 2. So that would be like over here, right? These are numbers that are smaller than 2. All of these, all of them from this in this direction. So what I did is I just kind of like put a line going like this. This shows that it's all of these numbers that fall like underneath here. It's all of these numbers, and it's all the numbers that are also in this direction. Now, if you see something that looks like this, say 5, right? Notice that this is an underline here. This is kind of like almost like an equal sign, right? If I had another line right here, it would be an equal sign. This symbol, and again, just to show you which direction this is, Pac-Man is trying to eat the X, right? So this symbol here, is that X is greater than or equal to 5. And what that means is if I go on a number line, so 5 here and -5 here, this is 0. Right? These are obviously, so these are numbers that are larger than 5. X is because x, this number here, Pac-Man wants to eat it, so it has to be bigger than 5. So I would, put my circle here, and it's all the numbers that are bigger than 5. That's all the numbers are in this direction. Now, to show that it's also equal to, and I notice that above here we didn't have any that were equal to. These were just either greater than, right? This is greater than, and this is less than. These are also, this is greater than or equal. And to show that, that means that x can actually be 5, and this would actually be true. This would say, because if I said 5 is greater than or equal to 5, well, 5 is not greater than 5, but 5 is equal to 5, so that's true. And to show that, this open circle here, we fill it in. This says that this is a solution, and so are all these numbers over here. Okay? So let's do an example. Let's do an example where we have to flip the sign, and just to show you that it does make sense. Let's say I have I guess maybe let's do like -5 is -5 is less than 0, right? Because it's to the left of 0 on a number line. So if, let's say I divide both sides by -1. So here, a negative divided by negative is positive, and 5 divided by 1 is 5. So I get 5 here. 0 divided by anything is just 0. Now, notice what happens if I don't flip the sign. So again, this is Pac-Man. He wants to eat the 0, right? Because it's bigger. Which one is he going to want to eat here? He's going to want to eat this one here, right? He's going to want to eat the 5 because it's bigger. So what happens to the sign? It flips. And again, this only happens when you divide or multiply by a -1. So let's try an example where we have to do that. So let's do something like, let's do 2x plus 10 is greater than 3x plus 12, right? So what I'm going to do, and I'm going to show you kind of like the layout, what I'm going to do. I like my x's to be on the left side, and I'll show you why. So what I'm going to do is I'm going to bring the 3x over here. How do I do that? I subtract 3x, right? So I subtract 3x here, and I subtract 3x over here. So what happens? This is 2x minus 3x. So that is 2 minus 3. That becomes -x. I still have a plus 10 here. It's greater than. So again, you can add and subtract. I subtracted, right? That's okay. That doesn't change the sign here. The 3x minus 3x, these go away. And so I have plus 12, or just positive 12, right? Again, so what I'm going to do now is I'm going to subtract 10 on this side, subtract 10 on both sides, actually, right? So what happens here? This cancels because it's positive 10. 10 minus 10 is 0. So what's left? I have -x is greater than, and then this is just 12 minus 10, or 2. Okay? So what I want to do now is I'm going to divide by -1. Or I can multiply by -1. It's the same thing in this case. Really what I'm doing is I'm just flipping the signs. I don't want this to be -x. I want it to be just good old-fashioned x. So this is going to be x here, right? And 2 divided by 1 is 2, but a positive divided by a negative is negative. So I have -2. And this sign then is going to flip, right? So now it's pointing to the right. Okay, so now this is going to point to the left. That's how I look. I don't really look anymore at what Pac-Man's eating. I like this, I guess it's pointing to the smaller number, right? To see, if it's greater than or equal to, I still use the Pac-Man thing, right? This is still eating the -2, so that means -2 is greater than. But when I'm trying to flip the sign, I just see this is pointing to the right, and now it's going to point to the left, right? Just to make it easier for me to see. So again, Pac-Man is going to be eating the -2. That means -2 is it's the bigger number. So now when I graph this, here's how I graph it, and this is why I like to have x on the left side, because this doesn't work if it's on the right side. What I'm going to do is I'm going to make my numbers here 0, 2, and -2. I always do this, and it's an easy way to do a number line. It's pretty simple. I don't have to write a whole bunch of numbers, but there's nothing wrong with that. If you want to have a whole lot of numbers, you can start from -12, go to 12. You can start from -5, go to 5. The only thing you need to make sure is that somewhere on that number line you have this -2, and I have it, right? So now notice that this is not equal to, so my circle is going to be open. I'm going to put a circle above the -2, And without doing any real calculations or doing any real math, what we're going to do is just look at this sign right here, right? That looks like an arrow, right? Almost like I'm putting it a little kind of like going this way, right? So now, which direction is that pointing? It's pointing to the left. So I'm gonna just draw my line towards the left and draw my arrow just like that. And that's it. It's not equal to, so I don't fill it in. Now, like I said before, to check this, what I'm gonna do is I'm gonna have to find a number that satisfies this right here, that x is less than -2. So I just need to think of a number that is over here, right? And let me go ahead and just make up a new number line real quick, just so it might be easier to see. So say here's a 0, this is 2, this is -2, and then it was all of these numbers this way. Now, when I said before about choosing 0 and you have 50-50 chance of getting a 0 as a solution, what I mean by that is that this, 50-50 just means, it's one or the other. So here 0 is not part of the solution, because what did I have? I had x is less than -2, and 0 is not less than -2, so I can't choose 0. If this was x is greater than -2, I would have chosen 0. Real quick, I just need to get my original equation. 2x plus 10. 2x plus 10. And that was greater than 3x plus 12, I think, right? Yeah. So what we're going to do is we want to choose a number that's just over here somewhere, a number that you feel comfortable using. So we can choose -3. I could also choose -4, -5, anything that's to the left of -2 on the number line. So what I'm going to do now is I'm going to plug that number in to this equation. So I'm going to go like this. That's 2 times, and that's going to be -3. Again, I could have chose -4, -5, -6, so on and so forth. Plus 10 is greater than 3, and this is going to be times, that's -3, and this is plus 12. So what's that? This is going to be 2 times -3 is -6, plus 10, right? Is that greater than 3 times -3 is -9, plus 12. Combining these, -6 plus 10, the opposite sign, so you subtract them, keep the sign of the larger, which is 10, so this can be positive 4. Is that greater than, and then -9 plus 12, again opposite sign, so you subtract, keep the positive, and is 3. So this is saying this. Is this true? Does Pac-Man want to eat the 4? Yeah, it's bigger, right? So this is a true statement. 4 is greater than 3. What that means is that this -3 is part of the solution. So if I plugged in -4, it would have worked. If I plugged in -5, it also would have worked. Now if I plugged in 0, though, it wouldn't work, because it's not a solution. Now let me show you why you want to use 0. So let's just make up a new one real quick. I'm going to try to make this work right. So say x, I'll make it this easy. X plus 10 is greater than 3x. Let's see. Minus, let's do, I don't want a nasty number, so I'm just trying to think. Try 8. Yeah, that should work. Okay, so let's just see what happens here. Right. So again, what we're going to do is we're going to subtract 3x on this side, and I'm going to subtract 3x on this side. Actually, you know what? Let me show you something that you could also do. If you don't like dividing, remembering that rule where you have to divide by a negative, what we're going to do is I'm going to subtract x on this side and x on this side, and the reason why is because now this 3x minus x, this will keep it positive, right? And so I'll never have to divide by a negative number. And this is okay. We're going to have to flip the sign later, but you can see why that might be easier. So either way works. I'll choose this way first. So this is going to be 2x. I'll drop down this minus 8, so this is minus 8. And the sign stays the same. And then these cancel, and what's left is 10. Right? So then I want to bring the 8 on the other side, so I'll add it so it cancels this here. If I add it to the side, I add it to the side also. So what do I get? 10 plus 8 is 18. And this is greater than 2x. And then one last thing, I'm going to divide by 2. So this is 9. This is greater than, and this is x, right? So now, remember, I like to write my x's first. So what I'm going to do is just go like this. I'm just going to write x here, okay? And then it's, being paired with this 9, so I'll put the 9 on the right side. Now I just have to ask, which are these, is this pointing at? This is pointing at the x. So we have to keep it pointed at the x. So this is going to be pointing at the x. And so again, Pac-Man wants to eat the 9. That means 9 is the largest number, right? So if I go ahead and graph this on the number line, put a 0 here, put a 9 here, put a negative 9 here. So which direction is this pointing? It's pointing to the left, right? It's not equal to, you know what? Yeah, let me go ahead, let me make this equal to. And the only thing that changes is the sign itself. This, it still has it here. This way you can just get a little practice seeing that when I have it equal to, I'm going to fill it in. I guess I'll make this in, I'll make it another color. I'm going to fill it in. Right? And then which direction is this pointing? It's pointing to the left, so it's going to be all of these numbers here. All of them. And it keeps going on, all of these numbers. So it doesn't stop at negative 9. It keeps going, negative 10, negative 11, so on and so forth. But notice that negative 9, I mean not negative 9, 0. 0 is part of the solution. And here's why, if I want to check the solution, I have to check one of these numbers. I have to check either 8 or 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3. I have to choose one of these to check it. Right? So if I can, I'll choose 0. 0 is easy to work with. So what is this? This is plug in 0 to the equation. So 0 plus 10, is that greater than or equal to 3 times 0 minus 8. The reason why this is cool is because what happens is that both the x terms actually just get zeroed out. This is kind of like disappear. And all I have is 10 is greater than or equal to negative 8. And that's true. Right? A positive is always greater than a negative. And I don't even have to think of the numbers. So that's why 0 is nice. I don't have to add these numbers or do 3 times some negative or positive number. They just completely cancel. So, when you can, use 0. And when I said 50-50, that just means that half the time, right? Half the time you will be able to use 0 because it's either going to go to the left or to the right, right? So no matter where you are on the number line, 0 is either going to be on the left or the right. If you can't use 0, okay, use something that works well, like 10, positive 10 or negative 10. It's easy to multiply by 10. 2 times 10 is 20. So that's pretty easy. And I guess that's really it. If you have any more questions, just let me know, and I can try to whip another video for you. Alright? And yeah, the other stuff, the other second set, just let me know if you have any questions on that stuff, and I'll make another video.